This is a lesson about solving trig equations. So when you're solving, remember you want to isolate a variable. And often we're going to use inverse operations and our algebra skills to make that happen. So here's a solve on the interval from 0 to 2 pi. So that means get all the answers. Think about it as getting all the answers on the unit circle from 0 radians, including 0, all the way around the circle to 2 pi, but not including 2 pi because that's an open brace there. So not including 2 pi, but we do include 0. It's a hard bracket there. Okay, so we have 2 sine of x equals root 3. So the first thing we should do is divide by 2. So now we have sine of x is equal to square root of 3 over 2. Now there are 2 wonderful places on the unit circle that have a sine of root 3 over 2, right? You've got right here at pi over 3, and you've got right here at 2 pi over 3. Those both have sines, right? Your y value of root 3 over 2. So our answer is going to be both pi over 3 and 2 pi over 3. And we're not going to go past that because we're really just told to stick to this interval. And if we didn't have a restriction, you could go on, right? You could go, to pi over 3 plus 2 pi over 3 plus 2 pi, and so on and so forth. But we are restricting our domain to just one rotation around the unit circle. It's really important that you try to remember your sine, cosine, and tangent for your special angles, your 30, 45, 60, but also your 0 degrees, 90, 180, and 270, right? Or 0, pi over 2, pi, and 3 pi over 2. Those are called quadrantal angles, right? So you want to just remember those special sine, cosine, and tangents for those special angles. It's good to have your unit circle handy. There's a link to this in the slides. Or if you have your own unit circle you like to use for these, it's just eventually you really want to get familiar with kind of having it be automatic. Sine of pi over 6 is 1/2. Cosine of 45 degrees is root 2 over 2. You really want to have these really automatic. It's going to help you find the correct answers to these. All right, so I just want to do 2 with you. Sometimes you need to use your algebra skills, and these are a couple of cases like that. So the first example here is sine squared of theta equals sine of theta. So you might be tempted to divide by sine of theta first, but you want to avoid doing that because it's going to eliminate one of your answer sets. So what we're going to do instead is since it's a quadratic equation, we're going to actually set the right side of the equation equal to 0. So we're going to subtract sine of theta from both sides. So that's going to be sine squared of theta minus sine of theta equals 0. And then we're going to GCF. We're going to take a greatest common factor. What can we factor out of sine squared of theta minus sine of theta? Well, we can factor out a sine of theta. And that's going to leave us, if we divide that out of the expression, sine of theta minus 1 equals 0. Okay. Now we're going to split the equations, or not split the equation, but split the expression and set each piece equal to 0. So sine of theta equals 0, and then sine of theta minus 1 equals 0. And so this is where you need to be comfortable with your unit circle. Where on the interval from 0 to 2 pi do you have a sine of 0? 2 places, 0 degrees and pi, or 0 radians and pi radians, right? And those are 2 of your answers. And then the other set of answers will be found in this equation. So we add 1 to both sides. Sine of theta equals 1. And now we need to know where on our unit circle, where do we have a sine of 1? And that's only going to be at pi over 2. So our answers that satisfy this equation will be 0, pi over 2, and pi. And that's that. Okay, so sine, the second example, 2 sine squared of theta equals 1. That's a little bit easier. We don't have to think about factoring because all we have is our quadratic term and a constant. So we can just solve normally, taking dividing by 2 and taking the square root of both sides. So if I divide both sides of the equation by 2, I have sine squared of theta equals 1/2. Then I can take the square root of both sides. So sine of theta equals plus or minus square root of 1 over square root of 2. Now, square root of 1 is just 1. And then I have the square root of 2. And that is actually, if I go ahead and do what we call rationalizing the denominator, getting it so that it doesn't have a irrational number in the denominator, just multiply by root 2 over root 2. That's going to give me plus or minus root 2 over 2. So sine of theta is actually plus or minus root 2 over 2, which is a sine ratio that we're familiar with. Root 2 over 2 is the sine of pi over 4. Negative root 2 over 2 is the sine of negative pi over 4. But because we're solving on the interval from 0 to 2 pi, we're going to take basically every 45-degree reference angle, right? Because pi over 4 has a sine of positive root 2 over 2. So does 3 pi over 4. And then 5 pi over 4 has a sine of negative root 2 over 2. And 7 pi over 4 has a sine of negative root 2 over 2. So this is going to have 4 answers. It's going to have an answer of pi over 4, 3 pi over 4. I'm writing vertically because I want to leave room for the last question. 5 pi over 4. Oh my goodness. 4. 5 pi over 4 and 7 pi over 4. So it has 4 beautiful answers. Okay, it's all these 4. Okay. All right, one more. So we have sine of x plus 2 sine of x cosine of x equals 0. Okay, so this, you might get a little bit worried about seeing 2 trig ratios, but notice that this expression, or 2 trig functions, this expression has a sine in it twice. So just like we factored sine out of this expression here, we can factor sine out of this expression. So let's go ahead and do that. So sine of x times something equals 0. Okay, so sine of x divided by sine of x would just be 1. And then we have plus 2 cosine of x. Okay, now we can split the expression up. So sine of x equals 0, and then 1 plus 2 cosine of x equals 0. And now we can solve it sort of more in a more predictable way. So just like with the first equation that we had to solve, right? Sine of 0 and pi is 0. So 2 of our answers are going to be 0 and pi. And then our other answer is going to come from this equation, 1 plus 2 cosine of x equals 0. So if we subtract 1 from both sides, divide both sides by 2, that'll leave us with cosine of x equals negative 1 over 2. Okay, where do we have a cosine of negative 1 over 2? That's going to be in 2 places, right? Again, you might want to look at your unit circle. So 2 pi over 3 has a cosine of negative 1/2. And so does 4 pi over 3. They both have cosines of negative 1/2. Okay, so those are the 2 x values that satisfy this part of the equation. So our full answer will be x equals 0, 2 pi over 3, pi, and 4 pi over 3. That's pi. And we're done with that. Okay. All right, so you are welcome to try. The week 7 homework is here. There's actually a key in the module as well. So you can give it a try, see how it goes. And that's pretty much all that we have for new learning today. Don't forget progress check is next Wednesday, and I hope you have a great rest of your day.